Good afternoon. Well, it's time to start the meeting between the NLA and international advisors. On behalf of the Nuclear Regulation Authority, I'm delighted to welcome you all, to the international advisors meeting. We met each other on October 30 last year. Since then, Mr. Jame joined the advisors. So let me introduce each advisors quite briefly. Dr. Dana Dravova, she's the chairperson of the State Office for Nuclear Safety in Czech Republic, and also she is the chairperson of the Commission on Safety Standards in IAEA. And I think everybody knows Dr. Meserve, Richard Meserve, former chairperson of the US NRC, Nuclear Regulatory Commission, and also the chairperson of the INSAG in IAEA. He had been a member of the international advisors from, I think it's the 2012, very beginning of the NLA. And Dr. Andy Hall, he was the chief nuclear inspector to the Office for Nuclear Regulation in United Kingdom, UK. And the new member of the international advisors, Mr. Philippe Jamet. He was a commissioner of the ASN France, and also he had been in a research organization, IRSN, and then the reading law in IAEA, and became a commissioner of the ASN. And also he had taken a leading role of the IRS mission to the NLA. Okay, so thank you very much for joining us. Today, we chose the two subjects for discussions. In this morning, one or two commission members give a brief about the two subjects. Their application of backfitting rule, and also disposal and clearance of waste, including a natural radionuclides. So let me take a few minutes to give a brief explanation about each subject for a few to several minutes, and then we would like to hear about your advice on each subjects. First of two, application of backfitting rule. Commissioner Yamanaka will give you a brief explanation of the background of our backfitting rule. Please, Yamanaka.
So this evening, I introduced the concept of application of backfitting rule in NRA, Japan. First, I showed the backfitting rules, and then the Specialized Safety Facility, SSF. NRA is responsible for setting regulatory requirement for prevention of disaster by use of nuclear energy under the Nuclear Regulation Act. In the Nuclear Regulation Act, new regulatory requirements are to be applied to existing nuclear facility, so-called backfitting. In the case of backfitting, basically the date of enforcement, deadline of implementation is set on a day certain time after enforcement of the new regulatory requirements, or moratorium period is placed for transition after enforcement. Even after enforcing the new regulatory requirements, NRA continues to collect the latest knowledge and incorporate findings into the regulatory requirements. Additional requirements are to be applied with certain deadlines. So next, I got in touch with Specialized Safety Facility, SSF. Based on the lessons learned from the Fukushima Daiichi accident, the NLA formulated the new regulatory requirements, including serious severe accident, such as ones caused by deliberate large-scale aircraft collision against nuclear power reactor building. Under these requirements, it is required to install the Specialized Safety Facility, SSF, in addition to measures using mobile equipment. The deadline of implementation of SSF is set to be 5 years from approval date of construction plan for main facilities. Since SSF is a backup measure for further improvement of reliable against SA, and certain time period is necessary for its safety reviews and construction. If implementation is not completed at the time when the deadline has passed, the nuclear facility would fall into the status of non-conformity with requirements. NRA can order the necessary operational safety measures, which includes that the NPP cannot continue the operation, to be taken under the Nuclear Regulation Act. So, thank you very much. That's all.
Thank you, Commissioner Yamanaka. Any questions? Or go ahead.
You had asked that we make comments on the rules, and I think that with regard to the backfit rules, I'll make some comments, and then each of us separately will add some comments. And then when we get to the second subject, Dana will take the lead on describing that. Let me first of all thank you very much for a very pleasant day, and this is, of course, a interesting and beautiful time to be in Tokyo as a result of the cherry blossoms. I left Washington in what was supposed to be the height of the cherry blossom season, and I've arrived at Tokyo. And fortunately, although I may miss them in Washington, I will have an opportunity to see them in Tokyo. And I think perhaps a better opportunity in Tokyo. I've just received an email from my wife who tells me that snow is predicted in Washington tonight. So our cherry blossoms in Washington may be short-lived. So let me turn to the backfit rules. And let me say, first of all, that backfit can mean different things in different regulatory systems. And I'll talk about backfit in the context that arises in Japan, where you set a deadline for compliance with a regulatory requirement that you have promulgated. And of course, some of your requirements are applicable upon promulgation, others, for good reasons, may be delayed. And I'd like to emphasize, talk about 2 points. First, the process that you might apply in setting the deadlines in the first place. And then secondly, turn to the question of how you should address a situation in which you come to the deadline and there is a facility is not in compliance. So first, with regard to setting the deadlines, we think it's enormously important, and some of this you may well do. I'm not suggesting that the things I'm going to say are necessarily practices that are not followed in Japan. I'm going to suggest things that should be done, as we think, as part of the process as a general matter. That we think that in setting deadlines, you obviously need to weigh, if you set a deadline that's different from the date of promulgation, it is obviously guided by several things. One is the safety significance of the regulatory requirement itself. If it's an essential, addresses an important safety issue, you may require it immediately to be effective, and if the plant can't comply, it should shut down because of the enormous safety significance. That's a very rare situation. Usually we would hope that you have a comprehensive safety environment already established. The plants are operating, they're operating safely. It would be unlikely that something so surprising would arise that causes immediate necessity of immediate, in all instances of immediate applicability, but that, of course, could happen. And I think that if you set a time different than the time of promulgation, it should be guided by the safety consequences of it, as I've indicated, but also the practicality. Is it possible to put the deadline in place, and what is reasonable time to allow for the increment on safety that the new requirement would allow? We would urge that that deadline should be set in consultation with the affected parties so that you have a full understanding of the implications of a new requirement and what its implications are, particularly for your licensees, that there may be practical challenges of which you would have no reason to be aware, but which they will be intensely conscious of. Let me say also, there could reasonably be some plant-by-plant differences, that some requirements may be much more difficult to place at one plant than at another plant. And that in thinking about what an appropriate deadline is, it might be appropriate in some instances to consider the plant-by-plant differences. And looking back at the specialized safety facility issue, where it may well be that I would expect the challenges could be very different for some plants than for others, and that some are very constrained site, for example, and actually locating the specialized safety facility could be difficult, might require massive excavation in order to allow the construction, that it would be reasonable to expect that it will take more time. And it seems to me one of the ways you could have handled that, and you might think about if a similar circumstance arises in the future, is that when you set the requirement, you could set a deadline within which to submit a plan to come into compliance, and have the licensee propose a deadline that you would then evaluate for its reasonableness. That would give you an opportunity to do plant-by-plant differences based on the guidance that you would have to determine it was appropriate. You couldn't allow them to delay forever, but you could make a judgment as to the appropriateness of a given deadline, and it could be different from one plant to another, recognizing the practical circumstances. We also recommend that if you do have a delayed deadline, there should be follow-up during that period until it comes into force to make sure that the licensee is aware that you're watching, that you're observing whether the licensee is pursuing the matter diligently, and give you confidence and that they're working hard on the issue, which will be important. There may be some other circumstances that some of my colleagues will suggest that ought to be weighed in considering what deadline should be set when you apply the backfit rule. The more complicated problem, I think, the more difficult problem arises if the deadline is going to be missed. And what do you do in that circumstance? It is our view that if the deadline is missed because the utility has not been seriously seeking to pursue it, that obviously is a time to get attention by the utility, and extreme efforts by you and appropriate sanctions might be appropriate, all the way up to suspension of operation in an extreme case. Perhaps something lesser than that would be appropriate. But you do need to have assurance that when you have a regulatory requirement, that your licensees are seeking to fulfill the requirements diligently. But we do think that, I was recognizing that some flexibility may be appropriate in some circumstances in which there is a failure to complete an operation of the installation of a new requirement. Particularly, there could be reasons could be technical challenges associated with the implementation, unavailability of equipment, or even an administrative challenge. In the case of the specialized safety facility, there's your current rule says 5 years after approval of the construction plan for the existing reactor. Well, the clock starts then. Then the applicant submits a license application for the facility, and then there's a period that is not controlled by the licensee about how long it takes for the NRA review. That's using some of that time period, but they don't control that. And it comes to the end, there has to be an inspection by the NRA too. They may not control how long it takes to do that. So there are aspects of the 5 years that are something that are not subject to licensee control, and that should be weighed. So we think that there are circumstances in which application of some flexibility could be appropriate. We think it might be sensible for you to set out some process that explains exactly the circumstances that you will consider in determining how to apply the backfit rule in this circumstance. The sorts of factors that you might lay out that you will evaluate include things like the reasons for delay. Is there something that was out of the control that no one knew about? Could be some piece of equipment that just isn't available, that there could be some part of the challenge of completing the project that was not appreciated at the time that can justify the reasons, even though they worked as hard as they could, that they couldn't meet the deadline. Another important factor would be the safety impacts of the delay. And if it's an incremental, marginal change in the safety of the plant, that is one that is not, you're still confident the plant can operate safely. And this would be an improvement, but it's not something that is essential to be put in place exactly at the deadline. That would be a factor you'd weigh. You might weigh whether the delay is one that could be accommodated by compensatory measures, other things that the licensee can do because given requirement is not in place that they can compensate for whatever that requirement would have done. We talked about the example in our meetings about detectors for a fire situation. Well, if you have fire patrols that are monitoring the facility, it may serving the same function as the detectors. And you could set the terms under which you allow that, and obviously it would not be something you would allow indefinitely. But it is a compensatory measure that compensates for the safety change that justified the new requirement. And of course, you may also weigh what exactly is the appropriate, if you decide that there has to be something that is done that maybe shut down to the plant is required, but as I understood the way the legislation was described, things short of shutdown might be appropriate. Compensatory measures would obviously be one possibility of penalties of some sort. There are a variety of other tools that might be available to you in order to deal with the situation. So we think it might be appropriate when, particularly in a time in which these regulatory requirements are of intense interest to the Japanese public, to lay out a process, a transparent process that explains what exactly you will do in evaluating a request for a delay in the implementation. And lay out the sorts of factors I've mentioned and perhaps some others that will occur to you that should be weighed in the analysis. And then when the request comes, you can take a process that's been defined in advance, explain exactly how it applies in this circumstance, and reach your decision as to exactly why you reached the decision. And the whole process would be open to public review, which ought to deal, at least in part, with the public concern that you've followed a reasonable, disciplined process to be able to reach the decision. And it also, as Andy has indicated, enables you to treat various of the licensees in a consistent fashion. That you have a set of considerations, and that it means there's a certain level of fairness that can be applied across your regulatory environment. So there's a series of thoughts we have about how you might approach the backfit process. And let me now turn to my colleagues to supplement my remarks with their additional thoughts.
Thank you. We don't generally talk about backfits in the UK, but nonetheless we have the equivalent of backfits as a result of periodic safety reviews on our plants every 10 years, and as a result of special reviews, for example, those conducted after the TEPCO's Fukushima Daiichi accident. Reviews take place and areas for improvements are identified, and as a result of that, plant modifications are proposed. The backfits ideally should come about when safety deficiencies and vulnerabilities are identified and should be proposed by the licensees in the first instance, because the licensees are responsible for safety of their operations, and so they should be proposing the backfits to meet the safety objectives and safety standards promulgated by the regulators. As Richard has said, the backfits and the implementation timescales should be set following consultation with the operators, so to ensure that the safety benefits are optimised and the timescales are realistic but not lax. I'll just pick up on a few of the points that Richard made. In particular, I think it's important to set out what the regulator will do if the timescales for implementation are not met. And I think that a way around that is to set out an enforcement policy and process that explains how the regulator will respond and what factors the regulator will take into account if an operator has failed to meet the required timescales. As Richard said, this could include all sorts of factors, such as the practicability of implementing the measures, the availability of equipment, maybe the need to undertake some of the modifications during a plant shutdown. It should also set out, though, the sanctions that are available to the regulator to respond to a failure to meet the deadlines, so that the licensee and others know what they may expect to happen as a result of missing that deadline. The process, the policy, shouldn't prescribe the actions that the regulator should take, but rather should lay out the options that are available and where the regulator has discretion to take one option as opposed to another, what the factors influencing that choice would be. So I think that that's important. The regulator and the operator should agree also how progress with the implementation of a backfit is going to be monitored, so that the regulator will be made aware at an early stage of emerging issues that might delay completion of the backfit, because that will make it easier for corrective actions to be taken if delays start to emerge. And also, if a deadline is missed, then the regulator should take action to maintain pressure on the operator to still complete the backfit as soon as possible. Because quite often, while the deadline's in place, the operator will feel under pressure. But once it's missed it, and it can't recover from that situation. So you need to have some alternative means of maintaining pressure at that point. Finally, I'd also reiterate the point that clearly the regulator must reserve the right to direct a plant to shut down if the risk it presents is assessed to be intolerable, although you would not expect that to happen very often. Thank you.
Thank you very much. I would like to mention one example or European experience, because after the Fukushima Daiichi accident, all European nuclear power plants went through an exercise called stress test. And the stress test analysis was aimed at severe accident prevention and mitigation options and their improvement, especially, not only, but especially. And what concerns the result and the topic we have discussed, that means the backfitting, I think it can be interesting for you to hear that during the stress test, only very few real safety issues were found, but a big number of cases for backfitting or improvement of severe accident measures. After stress tests, each country was tasked to provide so-called action plan. What measures? When? With deadlines. In fact, when we came back after 2 or 3 years to evaluate how the national action plans were fulfilled, we found that in each and every European country there were some deadlines for backfitting missed. And I can remember maybe 1 or 2 at maximum cases when the operation of power plant was suspended for a short time due to missing the the deadline. Why? Because after Fukushima situation, from the point of view of backfitting, is a really special one. Because in fact, you are not solving, at least in Europe, safety issues as such, but you are seeking the improvement of safety. That means the power plants themselves are safe, benchmarked to the regulatory requirements, and you introduce new requirements to tackle the new situation. But this is a bit tricky issue because backfitting in this case is simple, in principle, solution proposed or forced by a regulator, but it might seem in the beginning a bit overambitious from the engineering and technical point of view. That means to find a technical solution, proper technical solution for existing power plant responding to backfitting requirement may occur much more complicated that both regulators and licensees can imagine in the beginning. And I will come back to what my colleagues mentioned. If you see a really appropriate effort from the part of licensee to tackle the issue, then it's okay to be flexible with some delay. But of course, if your licensee is not responding at all, or responding, say, if you have 5 years deadline, and the licensee tries to respond in the 4th year, it's something quite different. But I would also plead for some flexibility in decision making.
Okay, so now I'm going to have the last presentation. And what I would like to talk about is the roles and responsibilities of the utility and the regulators in those two areas, setting deadlines and what happens when deadlines are not met. And I want to talk about it in line of the safety principle that the utility has a responsibility for safety. So if I start with setting deadlines, of course the regulators is stating the safety objectives with respect to the different risks that were identified. But then the utility has to propose practical solutions to deal with those issues and also deadlines. And then the role of the regulator is to assess the proposal of the utility, assess, of course, the deadline that is proposed, and finally impose or require or approve, if things are nice, the practical proposal of the utility and modify or accept the deadlines. And then, of course, at the last step, the utility has to implement what is required. What is important in this whole process is that what is finally required depends a lot upon the quality of what is proposed by the utility. Of course, if the utility has proposed something that is efficient and fast enough and reliable, he will have a big chance that the authority is requiring what he wants. So at this stage, this is a responsibility of the utility to make a good proposal. Now, how about the deadline? What happens when the deadline is not met? As Andy said, I think the first responsibility of the utility is to inform the regulators as soon as possible. The worst thing is that, you know, when there is half a year and 4.5 years have passed, then suddenly the utility says, no, I'm not going to respect the deadline. But this information is extremely important to monitor the process. The second thing is that this is also the responsibility of the utility to propose solutions. First, in order to try to catch up with the deadlines, And second, if it's not possible to catch up with the deadline, to propose compensatory measures that would allow to respect the level of safety up to the time then necessary to implement all the disposition. And finally, if he can, to justify why the deadline cannot be met and why the situation could be acceptable. And of course, then the regulator has to assess the proposal of the utility. And again, if the proposal of the utility is correct, especially if the safety level is respected up to the deadline or up to the implementation of the disposition, normally this is a good condition for the regulator to accept the proposal of the utility. And again, if the utility has shown that they have been neglecting the problem, not doing the best to meet the deadlines, then the normal procedure is that there should be some sanction. It can be financial sanction. It can be also shutting down the plant. But then again, I think what happens in case the deadlines are not met is largely under the responsibility of the utility. And this is what I wanted to highlight in my presentation. Thank you very much.
Well, let me try to quick response. I mean, first of all, regarding the period for implementation, I think it is generally accepted. I mean, everybody agreed about that. We need, we mean the utility and regulator should have a certain period for enforcement, because if if the regulator does not give any time for implementation, or it means if we always require immediate shutdown, well, we will never receive any proposal regarding safety improvements from the industries, because if they when they propose something, shut down all the facilities, that's ridiculous. So we need a certain period for implementation. And in our case, before we set the deadline, we we learn the situations of the licensees carefully, and we hear about the opinions from the industries. And then well, this is not a quantified process, but we, in the recent cases, which is fire detectors, in this case, we hear the opinions from the industries a few times, and then we set the deadline. And then the difficulty is when the deadline in utility cannot meet the deadline. We accepted any compensation. Well, the shut down the reactor is only an option of the compensation or compensatory measures. But utility has an obligation to prove their option, their proposal. They need to prove the adequacy of the countermeasures, and also they need to take a responsibility, again, the accountability of the measures. So, and I agreed, Mr. Jamed, if they have a possibility, a certain possibility of the possibility that they will not be able to meet the deadline, well, they need to speak out immediately, because we already have a few to several years after we give an approval of their construction. So, the discussion regarding the countermeasure, if they cannot meet the deadline, we need to have a certain time for the discussions and also a certain time for the assessment of the how much their option can be meet the regarding the safety significance and the other situations. And well, technically speaking, if we can quantify the risk increase when they do not have certain measures or certain facility, that would be this question became easier, but in many cases, it is very difficult to quantify the risk increase due to the lack of the facility or lack of the measures. And in particular, specialized safety facility, the facility is also for the countermeasure against the man-made event. And we do not know the frequency or possibility of the man-made event. So that it makes the problem more difficult now. So thank you very much for all the advice. And well, if it is needed, we need to have a careful process with the industries and with stakeholders regarding the period for installation, and also particularly in the case if one of the utilities will not be able to meet the deadline. Any remarks from? Okay. Would you like to add something? Okay. So this is the first subject. And we also asked the advisors to produce advice regarding the disposal and clearance of waste, including natural radionuclides. And in this morning, I asked Commissioner Tanaka and Commissioner Bond made a brief of the subject. So please, Commissioner Tanaka, give just a few minutes explanation.
Okay, just a few minutes. I'd like to explain our question, our considering issues for that. Okay, I'm sorry. Okay, one of the important subjects of NRA in this year is clearance and disposal of waste, including natural radionuclides. Typical one is uranium. Today, I'd like to discuss and want to have the international advisors review our view on clearance of uranium-containing materials. Currently, clearance level for uranium in Japan is 1 becquerel per gram for uranium-238, only for metal scrap. This clearance level was derived with a calculation based on scenario of 10 microsievert per year for public exposure, with the evaluation period of 100 years. Here, disposal in industrial waste disposal site, Sanpaijo in Japan, is not considered, as metals are required to be recycled under law. One of our challenges is how we can expand the scope of clearance, for example, to all material contaminated by uranium. When considering clearance level for uranium, IAEA Safety Requirement GSR Part 3 is important. It's shown in the table I2 for artificial origin and in table I3 for natural origin. Table I3 says 1 becquerel per gram for radionuclides in the uranium decay chain. In table 1-2, no figure for uranium-238. For uranium for clearance, natural origin or artificial origin is an important point, we think. For this, EU Council Directive 2013-59, shown here, is a good reference, I think. It says, for the clearance of materials containing naturally occurring radionuclides, where these results from authorized practice, the clearance level must comply with those criteria for clearance for material containing artificial radionuclides. Also, the next page table. This table shows UK's values of clearance level. Concept in UK is similar to that of EU, I think. This table shows 1 becquerel per gram for uranium-238 plus and 0.01 becquerel per gram for uranium-238 secular for both in practices. These values were evaluated based on 10 microsievert per year. When we consider the clearance level for uranium, we must understand the meaning, real meaning and background meaning of IAEA documentations, and also survey the regulatory practices in other countries. So the point we want to discuss, and also we want to have the comment from you, are 2 points. One is the value of clearance level for uranium may differ depending whether those from practices or not, for example, from non-nuclear industry. And the second one is, is it scientifically reasonable to use the order of 10 microsievert per year for setting the values of clearance level for nuclides which widely exist on Earth? Okay, this is our question.
Well, to discuss the concept of clearance is really hard work, and it's also a long-lasting discussion because it started, as far as I remember, already after the Chernobyl accident, and to find a consensus on this clearance concept and clearance values has not finished yet, maybe, and we discussed it also during the morning, the new document being prepared by the IAEA, that means the safety guide on application of the concept of clearance, may help to clarify and to contribute to international consensus. We discuss quite a lot what clearance in fact is, because clearance is a concept applicable to materials under regulatory control. That means to materials resulting from operation and decommissioning of facilities like nuclear power plants, research reactors, other nuclear fuel cycle facilities, industrial plants, medical facilities, research facilities, and so on. And it applies also to industries that process naturally occurring radioactive materials. But important word is practice. That means clearance is closely bound to practice. And once the material is cleared, then it is no longer subject to regulatory control. That means that from the legal point of view, it's no longer radioactive. And the residual radioactivity of cleared material may be disregarded. And this is really important. You have just mentioned, Commissioner Tanaka, that there is, say, good international framework what concerns generic clearance levels. And I underline generic clearance levels. This is IAEA safety standards GSR Part 3, and in the European Union, the directive called Basic Safety Standards for Radiation Protection. And what is really important is common dose criterion. Common dose criterion from the clearance of radioactive material from practice, and this is really 10 microsieverts per year. And it doesn't matter if it is artificial or natural radionuclide. This dose criterion is universally applicable. The other thing is that the clearance level is not a limit. It's really a generic value for regulatory decision making. And a regulator can decide to take the clearance level as it is stated in GSR Part 3, or to evaluate the situation as described by licensee or operator, and to decide on clearance levels that are optimized, taking into account the situation. This is another option, and you always have the possibility of graded approach according to activity or and amount of material to be cleared or disposed, because disposal is, and you know that better than me, something very different from clearance, because disposal is still regulated process. In conclusion to my introductory remarks to these topics, I would like to underline that the best advice we can give at the time being is to closely follow the development of international standards and recommendations in these topics. I have mentioned the safety guide being prepared by IAEA, but not only that, also to comment on that regarding the specific situation and issues you may face in Japan.
Let me supplement Dana's comments, which of course I agree with. The thrust of your questions were that you observed that the clearance level in terms of concentration is different for basically the nuclear industry, the practices from the non-nuclear industry. And let me, from a pure risk point of view, it makes no sense. And that if it's a given radionuclide, who cares where it comes from? It is, if you're exposed to it, you're exposed to it, and you have the risk consequences. And to have orders of magnitude different approaches from a pure risk point of view seems to be questionable. It reflects, however, I think, just the practical realities. The Earth is radioactive. Radioactive materials are all around us. And coming from the nuclear industry, you have the possibility of human activities that you can regulate it. And so you try to make those risks as small as reasonably can. Whereas you have a background that you can't, it's impractical to deal with. So that to some extent, the differences in approaches just reflect the regulatory circumstances in which you find yourself. And I think it does reflect to some extent a public consideration that things that happen in the nuclear industry are subject to intense public scrutiny, and higher levels of safety are demanded as a result of that. You know, but it does, now of course, as Dana's indicated, that the standard is a 10 microsievert per year type limit. And of course, the natural background is, 3 or 4 millisievert. So you mean that we're surrounded in an environment in which we're exposed at much later, the higher doses than we're talking about here. And it reflects this, what you control, what you can control. Let me say that I think the application of the 10 microsievert per year standard is challenging, because depending on the material, you have different exposure scenarios that are possible. That the exposure scenario for a metal that's recycled may be different from the exposure scenario from uranium that's in some other material, and how that will be handled and how humans will relate to it. And as we discussed this morning, the time period for the evaluation can be affected. If it's uranium that is not in equilibrium that you start with, the dose goes up over time as the daughter products come in, and you have a situation where all the decay chain is then present. So you have a situation that actually there's not only is the exposure scenario one in which you have possibility of very separate evaluations depending on the material, but there's a very delicate consideration how you deal with the time period. So that has to be factored as one of the elements you consider in the exposure scenario. Let me just make as a final comment that this is an area based on my experience in the U.S. and I believe in the other countries as well, that you have to approach with great caution. My experience is that for reasons I can't fully explain, public reaction to clearance is one that becomes of intense public interest and concern. Part of it, of course, is this material is removed from regulatory control. This is the last time you have somebody who has their grip on it and can compose regulatory requirements. And I know in efforts in the U.S. to establish sort of limits, for example, below regulatory concern, it was a rulemaking was just stopped dead in its tracks because of the intense public reaction to the idea that a trivial dose was something that nonetheless was unacceptable to allow. So I just want to suggest that this is politically fraught territory, and given the concern that exists for Japan for radiation-related risks, and justifiably so, that you need to approach this one with a great sensitivity to where the public concerns are. I fully concur with the recommendation that Dana expressed that there is available information that may be coming out, particularly with this IEA guide, that I understand will be available in the fall for comment, that may provide insights in this issue and certainly would benefit from the consideration of comments that you could have that reflect the application of that guide in Japan.
Thank you. I'll just briefly reiterate what my companions have said here, which I fully agree with. In terms of the UK, it follows the EU directive that all of the EU states have to follow, which in turn is based on IEA recommendations. And so for practices, doses must not exceed 10 microsieverts per year, and this does lead to lower concentrations for them than for normally occurring radioactive materials. This result is effectively a result of a regulatory philosophy, which says that for naturally occurring radioactive materials, these are not generally amenable to regulatory control, and you shouldn't try to control something that it is not practicable to control. You can only regulate what you can control, and so that is why there is the difference. But it does mean that in terms of the doses that arise, there is a dissimilarity there. That's the reason for this. Thank you.
Yeah, I want to touch 2 points. The first one is the practical application of clearance of material, and I have in mind dismantling of nuclear installation. I'm not going into millisievert or becquerel, but I just want to highlight that you also have to look at the practical aspects of this problem. How are you going to transform the material? How are you going to control those materials when they will be at very low level of activity? And if you think, for example, of several thousand cubic meters of concrete, and you want to ensure that any small particle of this concrete is under some threshold, this is not easy. And finally, the third thing is that even if you have controlled everything, it's not sure that we will find easily customers for material that are coming from nuclear installations. Because, for example, we knew the story of a car builder that didn't want any steel like this because he was afraid of the image of his cars. And so I think it's maybe this aspect of practical implementation should be looked at, and I know that in ASN they were very much impressed by a visit they made in an Eastern Germany plant that is actually dismantled, and they went to see how they were proceeding, and I think there are a lot of lessons to be learned from this. So this was my first point: look at practical feasibility application. This is not only a theoretical problem. Second one is that, and I want to echo what Richard said, the problem of low-level waste is not a problem of public or environment protection. I think it's a problem of reliability of the channels where those products are going. And as an example, we had in France a problem with buttons in elevators that were detected as being radioactive. And we spent such an amount of time explaining this was low radioactivity, no danger, and so on. But the cost of such a story in terms of time to explain to the public and loss of reliability or of image or credibility of the regulatory authority is very high compared to the effort you make to recycle material. And when I'm having a nightmare, I imagine that if instead of elevator buttons, this would have been pans that housewives would have been discovered as being radioactive, I think this would have been 100 times even worse. So think that you have to be very sure that there will be no failure in your system. And this is not so easy to guarantee. Thank you.
Well, thank you very much. Thank you again for your advices. Well, Ms. Drabova introduced about your ongoing efforts in IAEA producing the guide for the clearance. Well, look, I think it is natural that the requirements for nuclear power stations are different in different countries because the hazards against the nuclear power station is different in different places. But and also probably disposal, the rule for the disposal may be different in different countries because of the measure how to dispose the waste. But in terms of the clearance level, I think the many countries could have the identical level for clearance because the situations are not very different in different countries.
You are free, of course, and I have mentioned it, to use those generic clearance levels as mentioned in GSR Part 3, and this is strictly based on those criterion 10 microsieverts per year. Sorry. So this is the way how to unify it if you want, but you can have in a country a situation where it is not practicable, as Philip just mentioned, and in such case, again, the key word of this day is flexibility and graded approach, I would say, yeah? Because you can, and especially what concerns natural radionuclides, face the situation that those criterion 10 microsieverts per year is not practicably achievable. And then you have to decide on the second principle for clearance, and this is a general principle of radiation protection. That means optimization. And of course, you can also face the situation when clear the material from regulatory control is not possible, and you have to establish some regulatory control regime.
Yes, well, it's a quite difficult subject. For the artificial nuclides, I mean, we take a process to concentrate the nuclides and dispose in one place or some places. But as for the natural nuclides, I think it is a natural way to take dilution and return to the environment. But things are not easy like this. And also, Mr. Mizur pointed out this is highly related to the public considerations, and also this is highly connected to the life of the people. So we know we must take careful process before we make a decision or we set up the requirement. And also we keep having extensive studies about the international practices in each country. And also we will follow the discussions and of the guide production in the IAEA. Would you like to say something? Yeah.
Yes, thank you very much. Although I think data are very important, but not so easy to do that. But also I understand basic idea. I understand also how you can make our regulation in Japan. It also might consider the public, and also you said the philosophical or sometimes in the ethical ones. And also I direct ask Commissioner Barnes to say something about this.
Yeah, thank you. First of all, thank you very much for your comments. And we should recognize this is not just a technical issue, but also societal issue. And in reality, it is difficult to reach the consensus at the international level. And it is very interesting to know the practices are different between 4 countries. Yes, this morning I learned that. So with the same generic criteria, practices can be different. Then we should start from learning from other countries, so how they address this issue. Yeah, that is my conclusion at the moment.
But at the same time, we have, well, it's not very urgent, but it's there is a need to set up the requirement because we face the number of the decommissioning of the nuclear power plants, and also we have a variety of different problems regarding the waste, low-level waste, not only from the nuclear industries but also from research facilities. So in many cases, certain amount of the waste from the research organizations uranium-related waste. So I don't know. We should set the deadline, but we cannot put it forward so many years. So I think within a few years or several years, we need to set up the deadline. But before that, we keep discussing this issue and keep raise this issue as a problem we are now facing. So thank you very much. Any words to add? Anything?
Maybe if you allow me, on the clearance of materials from nuclear industry and nuclear research facilities, probably very seldom you will face the situation where the natural radionuclides will be the critical one in the mixture of radionuclides. When you have to decide which material to clear and which not to clear. There is one specific case, and this is concrete. This is concrete that can be contaminated by natural radionuclides. But especially in this case, I would say a specific approach should be established and written down. Of course, you always start with this generic clearance, dose criterion, but then you decide if it is for your situation applicable or not.
Yes, I agree. We need to know the state of the waste from the specific facility, and we need to define how to measure, how to quantify the dues or even the seatbelt or vehicle. Doesn't care, but we need to define the measure to quantify the level, and also we will face the problem of the homogeneity of the waste, So there are a variety of the difficult, different technical questions, and we will face. Anyway, thank you very much. Last word?
Good. Thank you. This has been a very interesting meeting, and I hope it's been helpful to you.
Yeah, thank you very much. Well, so thank you again for your coming from the long distances, and thank you very much for taking the time. And we most probably we will meet each other later in this year, fall this year. Thank you very much. So let me close the meeting. Thank you.